Hi, good day and welcome to my first video on areas and perimeters. Today, this will be a series of videos. We'll be starting off with the simple shapes like the squares, rectangles, then we'll do circles and move up to triangles, and then we'll be doing compound shapes. Alright, so be on the lookout for at least 4 more videos on this topic. Alright, so let's get started right away. Let's start off with question 1. Here we have a rectangle where the length is 20 and the width or breadth is 8 centimeters. Now I'm going with the assumption that you all know the basics in finding the areas and perimeters of simple shapes, because you would have done this in SEC. But let's review it in any case. The area of a rectangle is length multiplied by breadth. In the exam, if the examiner were to ask me to find the area, I would write the formula first for the examiner. Then, the length would be how much in this question? The length is 20 multiplied by the breadth, which is 8. So, 20 by 8 is 160. And since it's area and the unit is centimeters, it will be centimeters squared. So pretty easy question. I wouldn't expect you would get too much marks for this in the exam. But let's try the perimeter. Now the perimeter is the distance along the shape. Now the opposite sides of a rectangle are supposed to be equal. So if here is 20, then over here would also be 20. And if here is 8, over here would also be 8 centimeters. So to find the perimeter, we just add all the distances. Pretend you're running along the shape and just count how much centimeters you run. So 20 plus 8 plus the next 20 plus the next 8. And that will give me the total distance around the shape. On your calculator or using your head, you are supposed, if I'm not mistaken, 40 plus 16, you're supposed to get 56 centimeters. Now you notice the unit for perimeter is centimeters, not centimeters squared. And the unit for area, well, the area is the one with the squared. Alright, so a very simple question. I'm sure a lot of you all probably skipped this part because it was so easy. But I still want to do it as a refresher. Alright. Here we have a nice blue square. Now what do we know about a square? All the sides are the same. So here is supposed to be 6. Here will also be 6. And here will also be 6 centimeters. How do you find the area of a square? It's just side multiplied by its side again. Or you can put s squared, because s something multiplied by itself is that squared. And I'm going to do it this way. So 6 multiplied by 6, that's the length of each side, and that will give me 36 centimeters squared. Pretty simple. Alright, let's try the perimeter. The perimeter is just the distance along the shape. 6 plus 6 plus 6 plus 6. That's super easy. So it's 6 plus 6 plus 6 plus 6. That will give me 24 centimeters. And you notice the unit here is centimeters. Alright, so these are 2 very easy questions. Let's try some questions with tricks in them. Alright? Well, actually, I'm going to build up to a trick here. Alright, so this is question 2. Give me a few seconds here, guys. Get fast forward. I think that's the L button or the J button. Can't remember really. Alright. Let's start off with, let's see. Here we have a rectangle. Alright. We know the formula for the area of a rectangle is length multiplied by breadth, or some people might want to put the length by the breadth is equal to the area. They just put this on this side and the area on this side. And then let you know sometimes you see that difference. Alright. So let's say that the area, I came and told you that the area of this rectangle was 40 centimeters squared. So I came and already told you that the area was 40 centimeters squared. Let's get some space here. Right. Then I came and tell you, well, its length is 10 centimeters. But we do not know the breadth. So the breadth or the width is a mystery. So it's a kind of backwards question. I give you the area. Usually you have to calculate the area, but now it's given to you. And I'm asking you to find the breadth. Well, let's try this question. This is the formula for the area of a rectangle. Alright? So let's plug in what we have. How much is the area? The area is 40. The length is 10. And we do not know the breadth. Now I'm sure a lot of you all figured out what the answer for the breadth is. Because it's a very easy question. Something I would never bring in an exam. Right? You just need to figure out what multiplied by 10 will give you 40. And of course, the answer that comes to mind is 4. So you know the breadth is 4 centimeters. But like I said, this is a very simple example. How about we try something a little bit harder than this? Let's try back this question. Now, the only reason this question was so easy because we had such nice, easy values to deal with. Let's say that I come and tell you the area of this rectangle is not 40, but 38.25 centimeters squared. Right off the bat, you see this is not an easy number to be dealing with. And now I tell you the length is 12.8 centimeters. And you need to once again find the breadth or the width. Let's try the same method we just did. So, the area is 38.25. The length is 12.8. And of course, we're trying to find the breadth. So all we need to do is, we need to figure out what number, when multiplied by 12.8, will give us to the 8.25. I'm sure you're already thinking, but that's going to be pretty difficult because these are not easy numbers to deal with. There are very few people who can figure out what number, when you multiply by 12.8 mentally, that will give you this number. So this is where your algebra saves you. Transposing will save you here. Well, if we are trying to solve for b, that means we need to get b on one side and everybody else on the other side. So this 12.8 is a secret multiply. Well, not really a secret multiply, it is a multiply. When you throw across a multiply, you will get a divide. So let's divide it. And notice b alone is on one side now. Let's divide it, and that should give us the breadth. To the 8.25 divided by 12.8. And we get roughly, well, if we round it off, we are going to get 2.99. So the length, the breadth here is actually 2.99. And remember, I rounded off this answer. Right? If you use your calculator, which I advise you do when I'm doing the questions, we will be forced to round off. And I can actually prove that this answer is actually correct. Because if we take the length and multiply by the answer we got for the breadth, the length by breadth, we're supposed to get back to the 8.25. So let's try it. 12.8 multiplied by 2.99. And we get 38.27. Very close to the 8.25. The only reason this answer is different from this is because we rounded off the answer for the breadth. If we had used the entire answer and said length by breadth, we would have gotten exactly to the 8.25. Alright, so these questions are very popular in the exam. I call them reverse questions, where they give you the area first and you try to find something, the missing side that would give you back the particular area. Alright, let's try another question here on, well, that's a rectangle. Let's try a square question. A reverse square question. let's take the pink one here. Let's say that I had a square and I told you the area of the square was 144, let's use meters this time, meters squared. And I need you all to... Alright, so we've been given the area of this square. And we are asked to find what is the length of one side of this square. Now, this is a primary school question, right? Area of a square is side multiplied by side, or, remember, side multiplied by side is side squared. So we've been given the area as 144. And to figure out what side is, well, the length of one side, we need to figure out what number, if we were to square it, would give us 144. And of course, the answer that comes to your mind is 12, because 12 squared is 144. So you know the length of each side is 12. So the length of each side is 12. Now the examiner can make the question slightly harder. Instead of finding the length of one side, he can ask us what is the perimeter of the square. So once we figure out the length of one side is 12, then the perimeter is the distance along the square. 12 plus 12 plus 12 plus 12. So the perimeter, I'll just put PER, would be 12 plus 12 plus 12 plus 12, better known as 12 multiplied by 4, which will give us 48 centimeters. Now, once again, this question was only easy because it was really easy to figure out what number, if we were to square it, would give us 144. And we can do that mentally. But let me change the question to make it slightly more difficult. Let's take this same square, right? And instead of the area being 144, let the area be 216 centimeters squared. And I want to know the length of one side of the square. The length of one side. Of course, all the sides have the same length. So let's put down the formula for the area of a square. Area of a square is side multiplied by side, or side squared. So the area is 216 and s squared. Now you're realizing this question is not easy like the other question. What number, if we were to square it, would give us 216? Most people can't do that mentally. So once again, algebra is going to jump in to save you. Remember in maths, if you have an equal sign, remember the last one, when we throw across the multiply, we will get a divide. When you throw across something, you always get the opposite. So multiply becomes divide. So if I have squared and I throw across squared, the opposite of squared is square root. Squared and square root are completely different. They're opposites, right? A lot of students think squared and square root are the same thing. On most calculators, let me show you this one time, right? This is just the calculator I have. I just hope that you can, hope I don't make a mess there. Let me bring the arm. I'm gonna bring this closer. Alright. Can you all see there? Trying to get to zoom in here. It's not zooming in. Alright. So now it's zoomed in. So let me get something to point with. What can I point with? Alright. You'll notice there's a squared button here. Right? I want to bring it closer. Right. So there should be a squared button somewhere there. Right. Now this here is squared. Anytime you want to square something, you just press that button. So if I want to say 5 squared, you'll get 25. But if I want to find the square root of something, you'll notice on top of the squared button, there's an orange square root. To get that, let's say I want to find the square root of 49. I have to press second function x squared, but when I press the second function, x squared, the square root will come up on top. And then I type in 49. So the square root of 49, as you all know, is 7. All right. So I just wanted to make sure you all could do that. Right. So back to our original question. 216 is equal to s squared. So I want to solve for s. So I'm going to take the squared and throw it across. But the opposite of squared is square root. So how much is s? I have to find the square root. So I have to press second function, x squared, 216. And when I do that, I get roughly 14.70. So the length of one side is 14.70. And if the examiner were to extend the question now and said, hey, after you find the length of one side, please find the perimeter, then we would have to add 14.7, 14.7, 14.7, and the next 14.7. So if he were to ask us to find the perimeter, it would be 14.7, and we are adding it 4 times. So we can save time by multiplying it by 4, and we will get 58.8. All right. So I really hope that you understood those reversed questions. All right. So let's try a kind of compound shape involving squares and rectangles. And let me see if I can try my best to trick you up here. All right. So let's do a compound shape. A compound shape, well, a compound or composite shape, are shapes that are made up of different shapes. So if you look at this object carefully, in the middle you will see a rectangle. On top you will see a smaller rectangle, and this shape here is actually a square. But how do I know over here is actually a square? You will notice I have these little lines here. These little lines means that any line with this orange stroke all have the same length. So 1, 2, 3, and this dashed line only has the same length. If all 4 sides are the same length, it's a square. So what we're going to do first, I'm going to do 2 questions. We're going to find the area, and then we're going to find the perimeter. So let's get started. Anytime I have a compound shape, the first thing I try to do is separate it into 3 shapes. So I'm going to call the middle one A, this small rectangle B, and this square C. So what we're going to do, we're going to find the area of A, then we're going to find the area of B, and then we're going to find the area of C, and then add all 3 answers together. So let's get started. You'll notice some sides are missing, so I suggest that we figure out those missing sides. Let's see. What's the easiest one? We know the distance from here to here is 10. We know the area of a rectangle is length by breadth. You all will notice that the length is missing from here to here is missing. So let's try to reason it out. If here is 10 and from here to here is 7, that means over here is also 7 because it's opposite to the 7. So that means from here to here alone is 7. Which means if this whole thing is 10 and here is 7, then over here has to be 3 because 3 plus 7 will be 10. So if here is 3, then the opposite side will also be 3. And of course, if here is 2, the opposite side here will be 2, this dashed line. But that's really not necessary. So I'm just going to just erase this 3 because here and here is the same length. All right. For the square, we don't know the length of the side of the square. But let's try to reason this out. Let's try to get the length of this entire line. From here to here is 15, and from here to here is 2. Remember, over here is 2. I'll write in 2 here. So what's the full length of this line? Well, the full length of this line should be 17. 15 plus the 2 gives me a full length of 17. So if here is 17, then the opposite side also has a length of 17. So from here to here is also 17. If the whole thing is 17 and here's 8, then this dashed portion here should be 17 minus 8. You understand that, right? The whole thing is 17, not 15. The whole thing is 17. Bring it down and minus 8 from it. So 17 minus 8 will give us 9. So that means over here is 9. And because of the little strokes, here's 9, here's 9, here's 9, and from here to here is 9. Alright, so let's find the area of A, B, and C. All of them, well, for area of A is length by breadth. So the length, don't be fooled, the length is 17. From here to here is 17. And the breadth is 7. Alright, so let's multiply that here. 17 multiplied by 7. And we will get 119 centimeters squared. Let's work out the area of B. The area, well, this here is, I should probably put this is, I'm trying to not mix up the working. So this was for A, shape A. Alright, let's do the working for shape B. Area is length by breadth. For shape B, length is 3 and the breadth is 2. So it's 3 multiplied by 2, which will give us 6 centimeters squared. And this is the area of shape B. Let's do C now. C is actually a square, right? So area is just side multiplied by side, or side squared. Each side is 9, so it's just 9 multiplied by 9, which is 81 centimeters squared. To get the total area, we just have to add 1, 2, 3 answers, and we are completely finished. 119 plus 6 plus 81. And that will give us 206 centimeters squared. Alright? So that's it for the area, right? But we still, well, let's assume that the examiner also asked us to find the perimeter. This is the one that gives a little bit of problem, because when you are doing the perimeter, you're going to pretend you are running around the shape, not through the shape, around the shape. So since this one has so much sides to run around, let's designate a starting point and a finishing point. Let's say over here is the starting point. So let's put S. And it's a race. So the person has to run around the shape. And when they make it back to the starting point, the race is complete. But that person needs to calculate how much centimeters he ran. Please note, you are not running through the shape. So you see this 2 over here, he's going to be irrelevant. When the person is running here, they will not be running through the shape. They'll be running around the shape. So this 9 is irrelevant. So let's figure it out. I might have to write vertical. So if we run from here to here, that's 15. Right? Or run from here to here, that's 3. That's 2. How much is from here to here? Well, if here is 3, over here is also 3. When you run from here to here, remember we reason out from here to here is 7. From here to here is 8. 9. 9. 9. And then 7. So we just need to add up all of these numbers and we will get the perimeter. You'll notice we did not run through the shape. We just ran around the shape. So 15 plus 3 plus 2 plus 3 plus 7 plus 8 plus 9 plus 9 plus 9 plus 7 gave us 72 centimeters. And you notice it's just regular centimeters, not centimeters squared. Alright. So Let me see if I could come up with another question involving squares and rectangles that will get your head thinking a lot. Alright, excuse me 1 second. So here we have another question. Let me explain the scenario. Let's say someone had a garden and the dimensions of the garden was 32 meters by 20 meters. From this whole thing is 20 and this whole thing here is 32. Then one day they decided to dig the garden and put a pool. Now obviously the pool is fitting inside of the garden, so it's smaller than the actual garden. And the distance from here to here is 1.5. We're going to assume it's symmetrical. So if here is 1.5, over here is 1.5. And if here is 2, over here is 2. What we want to do, we want to find first, well, the aim of the question is to find the area of the green part. The area of the, let me shade it here for you, of the green part only. Right now, the green part is just the piece around the pool. So we want to find the area of the green part. Now, here's how I suggest we do this. We find the area of the big rectangle, and then we find the area of the pool, which is a small rectangle, and we minus both values. So, this is what the formula, this is what it will look like. We're going to find the area of the big rectangle, and then what? Minus the area of the pool. Now, the pool is the small rectangle, and once we minus both of them, it will leave us with the borders. So let's find the area of the big rectangle first. That should be really easy. Length by breadth. Length by breadth. 32 multiplied by 20, I believe that's 640, well, let me double check it. 32 multiplied by 20 is 640 meters squared. But for the small rectangle, the pool, we don't actually have the dimensions, but we could reason it out very, very easily. Think about it. If this whole thing is 20 and here's 2, remember we're assuming it's symmetrical, that means the opposite side is also 2. So here's 2 and here's 2. That's a total of 4. If this whole thing is 20 minus 2 and the next 2, that will leave us with a piece there. So it's 20 minus 4. That means from here to here is 16. And if here is 1.5, then over here is also 1.5, assuming it's symmetrical. The whole distance is 32. Look at it. From here to here is 32. So from here to here has to be 32. If we take 32 and minus 1.5 and minus our next 1.5, it will leave us with the length of the pool. So 1.5 plus our next 1.5 will give us 3. Take that 3 from 32. 32 minus 3 and we will get 29. So that means the pool, to find the area, will be length by breadth. The length is 29. The breadth is 16. Okay, so let's try that. 29 multiplied by 16. 464 meters squared. And we said we would minus both answers. Let's take it. 640 minus 464 will give us 176 meters squared. So the area over here, sorry, the area around, that's what is left, is 106 centimeters, sorry, meters squared. Alright, so that's a pretty popular type of questions in exams. Alright guys, so I think this was a lot of examples on squares and rectangles. In my next video, I'm going to do circles. Everything you need to know about areas and perimeters of circles.